Hi everyone, it's Coach Fred here, and today I'm going to be going over just some general topics from Algebra 2. And I want you to know this is certainly not the way I would teach it to you in a class. But if you're getting ready for the ACT and you did not get to cover circles, ellipses, and hyperbolas, we refer to those as conic sections in Algebra 2, then I thought that this might just be a great introduction. So I imagine, though, that at some point before now, you have learned the equation of a circle. X minus h squared plus y minus k squared equals r squared. Now remember, a circle is a set of points the same distance away from a point called the center. That distance is called the radius, and it's equal all the way around. In this equation, x minus h squared plus y minus k squared equals r squared, well, hk would be your center, and your radius would be r, not r squared, so always be careful of that. So if I give you an equation like x minus 5 squared plus y plus 3 squared equals, 16, well, then your center would be 5, negative 3. Notice the opposite signs there, and your r would be 4. Now, what you should notice about the circle and the ellipse is really that an ellipse is actually a flatter version. It's either being squished, really like squished like a pancake this way, or squished like a pancake this way. And so we are actually doing something to the ellipse or to the circle. So you might notice that the equation of the ellipse, x minus h squared plus y minus k squared, is still there. But they're both being divided by numbers. A squared and b squared in this case, and they equal 1. They're still being added because it's very similar to a circle, but we can tell if it's going to be a vertical ellipse or a horizontal ellipse by the values that are under the x and the y. If the value under the x is larger, then it's going to be looking like this. And if the value under the y is larger, it's going to look like this. So it's going to be, I'd call it a vertical ellipse. The big thing that I've seen on the ACT is not that you have to come up with the equation, but you have to recognize the difference between the circle, the ellipse, and then the hyperbola. Take a look carefully at the hyperbola for a second. Doesn't look like a circle or an ellipse, so they're not as related, although it's still called a conic section, and it still comes from the same figure, a cone, and it still has x minus h squared and y minus k squared. But you might notice that the hyperbola is being subtracted. And although this hyperbola I gave you looks like that, a hyperbola can also look like that. That's determined by where the a and the b, or where the larger value lies. If it lies under the x, it's going to look like this. If the larger value squared lies under the y, it would look like this. If the y is first, I could write y minus k squared plus x minus h squared equals 1 all over a squared and b squared. If I write it like that, then it would look like this. But again, you're not going to be responsible for coming up with the equations of the hyperbola. You really are going to have to just focus on what a circle's equation looks like, how it's different from an ellipse's, and how it's different from a hyperbola. And so I always refer to that plus and that minus, and that helps me. So here's a great example. It's a question number 53 on the ACT, so you know it's going to be a harder level. But this is really just content knowledge. A hyperbola has vertices 1, 2, and 3, 2, and that passes through the origin, is shown below in the standard coordinate plane. The fact that it tells me it passes through the origin is always going to be important. Always consider that. That means that the point 0, 0 is on the graph, and no matter what the question reads, you always have to think about that. All right, and it says the hyperbola has which of the following equations? I quickly vertically scan. Remember that vertical scan method's important. I vertically scan and I see the pluses here. These are out, okay? Then I have to look at the center. So the center is right here, right? And that looks like that center would be 2, 2, 2. Okay, and that's my H and my K. So C is out as well. So the only difference I have here between A and B is this 3/4 or 4/3. Because I said you really aren't going to have to come up with that on your own, that's where this other point can help. We got to remind you over and over, if you have an equation with x's and y's in it, then if you plug that point in, it's an equation, it should make the equation true. So I'm going to plug 0, 0 in and see if what it does for me. So 0 minus 2 squared over 1 minus 3 times 0 minus 2 squared over 4. Does that equal 1? That would be A. All right, so 0 minus 2 squared is negative 2 squared, which is 4. 4 over 1 is 4. 0 minus 2 squared again would give me 3 times 4 over 4. So that would give me 3. It does equal 1, so my answer would be A. All right, so that's my quick review of circles, ellipses, hyperbolas. Hopefully it was helpful, and if you liked it, give me a thumbs up.